Okay, there are many important irrational numbers used in mathematics. Likely the most likely one, the most known is pi, which is the circumference of a circle divided by its diameter. Using pi, we can determine the circumference and area of a circle. So that's like old stuff. Then we have e. Notice, I want you to take some notes on this. This has to be lowercase, and it's really also italic, which is hard to do when you write it, but it's just like a little curly lowercase e. It cannot be used with capital. This is a symbol that is a math symbol that has meaning, okay? So an equally important number is known as Euler's number e. It's found in many mathematical formulas, such as those used to describe nonlinear increases and decreases, shapes of hanging cables, arches, and several probability formulas. The most frequently found place in everyday life is its use in calculating compound interest, which is where we're going to use it. The value of e is 2.71828 blah, blah, blah. Remember, it's irrational, so it goes on. It was first introduced by mathematician John Napier in his development of natural logarithms, which we are not going to do right now. However, it was Leonard Euler who investigated and discovered many of the number's amazing properties. The following pages will give a couple of examples on how e is calculated.
So how do you find, how do they keep finding new digits to file?
You're going to see. So let's just stay with me. So if we turn the page, you do not have to write your name on every page because I stapled them together. So there are many different ways to calculate the value of e. Since e is an irrational number, none of the methods give an exact answer. E is usually defined by this. Now this is getting into pre-calc and calculus. So that symbols, don't get freaked out about it. But what it's going to do is we are using this formula. So see how this looks very similar to that compound interest formula that we were using before? What they're doing is they're putting in bigger and bigger numbers for how many times a year. So we're going to make this number and this number. So if I make that 1 and 1, it comes out exactly 2. If I put in 10 and 10, it comes out 2 point this. If I put in 100, 1,000. And so they're making these numbers bigger and bigger. And so it's like, what if I could compound interest daily? What if I could compound it hourly? What if I could compound it every minute, every second? And then it gets to the point where what if I can just keep infinitely adding interest? And so that's where they came up with E. And so as you put bigger and bigger numbers in, this gets closer and closer to E. And so they program this into a computer, kind of like they did with pi, and it keeps spitting out more and more decimal points. And then this is another method, and this allows me to show you something else. So this is called a factorial. For my knowledgeable people, I'm going to teach you what factorial means over here to the side.
It's like 1 plus 1.
So if I have 4 factorial, that means 4 times 3 times 2 times 1, which is 24. You multiply every number from that number down to 1 whole numbers. So if I was doing 6 factorial, it would be 6 times 5 times 4 times 3 times 2 times 1. They ask those every once in a while, and basically you just have to do some quick multiplying. So what they've done is they're putting that as the bigger and bigger factorial in the denominator, and that is another way that you can do it. There's an exclamation point on these calculators somewhere. It's probably in a menu. So let me just show you that. So I think it's in math. Okay, so if you hit the math key, you have all of these like menus across the top. If you go over to prob, which stands for probability, there's a little exclamation point here. So you can enter the numbers with that. So if I go back to my main screen, if I'm just doing a regular factorial like we were doing, I could do 6. Go to my math menu, go over to probability, get number 4, and it's going to go ahead and do all the multiplying for me, which is especially nice if the numbers get really big, like 8 factorial. So what they're doing is they're doing this in a sequence. So it's 1 divided by 0 factorial, you get 1. So that's 1. And then I'm adding to it 1 divided by 1 factorial. Man, it's a pain to go find that. I wish there was an easier way to do that. And you get 2. And I'm adding to that 1 divided by 2. In fact, we won't do all of them, but it kind of gives you the idea of how this works. It keeps adding on, and you get more and more decimals as you make this go further. And that's kind of where pre-calc starts. We're not quite ready for that, but it's showing you a couple of different ways. This one is going to be a little bit better understood.
So is that chart is just E, it's not compounding interest, right?
Right. Well, it's related. It's related. So let me show you how we could put this in. We'll just go to, no, I'll show you. So let's put this in as a formula on our calculators. So if we go to the y equals menu, that's where we usually put stuff to graph. Let's graph this and take a look at it. So in the y1, we're going to do parentheses, 1 plus, and then you can go in and get that fraction thing if you want, or you can just use the division key. And then we'll have to use x, which is this key right here, instead of n, but it's fine. And we'll right arrow, close the parentheses, and then to the x power. So we have to use x instead of n, but it looks the same. Do what?
What's below the 1?
It's an n on your paper. It's an x on the calculator. So then what we can do with this is a couple of things. We could look at the graph. So if I look at the graph, what you're going to notice is it kind of looks like a straight line until, whoops, it's not. And then it kind of jumps a little bit. This is your positive half where we would be looking at things like interest rates. It's growing, but it's growing slowly. Okay, it's kind of like the inverse of an exponential. It grows fast and then it kind of levels out. So basically, if I start adding interest every minute, every second, every nanosecond, eventually I'm not going to add a discernible amount of interest and you're just going to be paying the same amount. And that's where this comes out. So if you hit the trace key, you'll get a cursor. Actually, you might have to hit trace and then the right arrow. And then this cursor will show up, and as you go across, this number is going to get closer and closer to E. It takes a little while, and it'll scoot your screen over, I think. It does on mine. And it'll eventually get to like 2.71 something, so it just kind of keeps going and going and going and going. And it levels off. Like, it isn't changing as much as fast. And you really have to get out there a ways before we're actually going to get to where it is. So while you're in trace mode, it has the points down here. I'm going to see if it'll let me do 10,000. So I'm just going to type 10,000 and enter. Okay, no, it won't. Okay. So what I also can do is then also go to the table. So if you hit second in the graph key, you can go into the table, and I'm only really, oh, I forgot mine's somehow on fraction mode. There it goes. I don't know why it was. So I can jump and just kind of go down the table too. And eventually, if I get to really big numbers, it's going to be 2.71828. Do we want to sit here and keep pushing that key forever?
Yes.
Probably not. There's another trick too. If you have the table, above window, it says like TBL set, table set. If you go there, you can tell it where to start. So if I want to start at like 100, I can put that in and then go back into my table, and it'll start at 100 instead of starting at that other point. So I can kind of skip over a little bit. So now it's at 2.7. Then I can go back into table set and be like, okay, what about 1,000? Go into the table. It's going to take a minute. And then it's starting to look more and more like E. So notice you can't even see a change anymore when I go to 4 decimal places. So when we're talking about money and we're only using 2 decimal places, you eventually kind of hit this point where you are not going to earn any more interest by charging it more often. So usually like,
Compound interest?
so we are compounding interest because we add interest to the interest, but even compounding it, it levels off. And eventually it won't go any higher. Now this is E, this is not the actual interest, but it's related. We're gonna do a new formula tomorrow, and we're maybe gonna get there here. Okay, so turn to the next page. So it says E is used in the natural exponential function f of x equals e to the x. I'm gonna show you where E is on the calculator first. So if we just go back to our regular screen, you do second and quit or hit clear a couple times. E is on here a couple of places. Does anybody see where E is on the calculator? Okay, so above, and it's actually ln, but yes, so there's an e to the x over here, and there's an e above the division key. So if I do second and the division key, it'll put up just e, and I can hit enter, and it's going to give me what the number is. The other one, if I do the e to the x, is going to give me e with some power, which is what this is talking about. And that's what I would use if I was going to graph it, which we can also do. So go back to your y equals screen, and don't delete this first one. We're just going to turn it off. Do you guys know how to turn them off?
Where is the x?
Huh?
Just put the x below the 1. Where is
This button right here, which I did point at multiple times, but it's okay. You might not have been there yet. Okay, so now to turn that one off, because I don't want to see that graph, I'm going to put a new graph. You put your cursor over the equal sign and hit enter. And then when you come down, it won't have a box on it, but that if I want to go back to that, it's still there. We're going to put e to the x in here. So I'm going to do second. I'm going to hit that ln key. It does look like in. It's supposed to be lowercase ln. And then the x is this key right here. This is where you're going to get the x for all functions for all time, that button. Now, that one, automatically when you put a function in, it turns it on. But I just messed up my screen. So I'm going to do a quick zoom, and I think 6. And it'll put me back on a normal window. And you can kind of see that this is exponential. So E is that 2.718 blah, 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 blah. If I make that my base and X my power, this is what that exponential curve looks like. Okay? And then it says what's interesting about this function is at any point the slope equals the value of e to the x. In other words, its slope is its value anyway, that's probably going a little over our heads, but basically if I go to 1 right there, it's kind of has a slope of 1 for that instant. And then it'll have, or a slope of e, and a slope of e squared, and a slope of whatever, because that's how we put it in. And so calculus is based on that, and then some other stuff. We are not going to worry about the rest of that page for right now. We're going to turn over. I wish these were, it is numbered. So at the bottom, it's page 4. You can just barely see it. It's the bottom of page 4. This is what we are going to be doing with it. Our application is continuously compounded interest. So we are going to imagine we can add the maximum amount of interest forever that you could ever get, because it levels off and eventually there's like a limit. That's actually what they call it in math, to how much interest you're going to get out of somebody. Even if you're charging them every nanosecond, it's not going to be that much different than if you're charging it every second. Okay, so this is our formula. I call it the PERT. Okay, I call it the PERT formula. So A of t is the amount that you have after t years. So they're using like a function notation there. You can just call it A if you want to. It's your principal times our number e to the RT power. So I call it PERT, P times e to the RT. But you have to remember the RT is in a power. So principal is there. R is still our interest rate per year, and we're still going to put it in as a decimal. So we might want to make a note, decimal. And t is still the number of years. But this is if we are continuously compounding. Now, how you know when you're reading a problem if you're using this formula or the other is if it's going to say continuously. If it says it's compounded quarterly, that's going to be 4 times a year. If it's compounded monthly, that's 12 times a year. If it's compounded annually, that's 1 time a year. But if it says compounded continuously, suddenly we're using this formula. And somebody's already worked out, using all of their calculus and all of the things, that E is the base that makes this work and helps us get that maximum amount of interest. So it says you invest $4,500 into an account in which the interest is compounded continuously. Complete the following tables for the amount of money you earn given a specific interest rate and specific number of years. So here's our interest rate, 3.1%. We're going to need to change that to a decimal, so we've got to go zoop, zoop. So it's going to be 0.031, and then t is just 5, and we'll get our amount. So how we're going to set this up is we're going to have 4,500 times e to the 0.031 times 5. times 1 because we're starting with 1 year. So going back to my regular screen, I'm going to put in 4,500, and then I'm going to put in E with the power. You can use the other E in the power key, and it also works. 0.031 times 1. So they're showing us this is just after 1 year. They want us to compare this a little bit. And so that comes out $4,641, and it'll round off to 68 cents. So 4641.68. Now that we've kind of got that set up in our calculator, I'm going to put a little dollar sign here. We won't necessarily have to write it out every time because I can just copy and paste. So I'm going to hit my up arrow a couple of times until I am highlighting what I just typed in. Hit enter, it'll paste it, and you can use your back arrow and change the 1 to a 2. Unless you want to type it in every single time, that's also fine. So if I put in 2, they're going to make 47.87 and then 83 cents. And then once you copy and paste, it becomes pretty easy. So I'm going to take this, hit enter again, go back up here, change it to a 3, and then we're going to get 49.38 and look, it's 577. So we got to round that up to 58 cents. If you're investing, you want that penny. Okay, and I'm going to go up and copy that one again. And then do this again. I'm going to get $5,094.07. And I'm just going through the pattern, so if you get a little ahead of me, that's fine. If you're a little bit behind me, also fine. I'm going to pause here in just a second. So here's what I got when it was 5. And we're just going in and changing just that time because that's the only thing that's changing. And so you are making more interest over time.
In 6 years, you made like $1,000.
Yeah. Okay, good. We did it right. I'm just checking the answer key. I did not mess anything up.
Pretty good, making $1,000 off of nothing.
Yeah, it is. And so, I mean, if it's you're putting it in there, you're not touching it, and they basically pay you money for putting your money in like if you're investing in a savings account, what the bank is doing is they're taking your money and they're loaning it out to other people who then pay interest, and then you get interest for putting your money in there, which is why when the stock market crashed, was it 1929 or 1930? I think it was the end of 29. Everybody went to the bank and wanted to withdraw all their money and have it in their hands. Well, what happens is your money isn't all sitting there in a safe. It's going around, it's being invested in all your neighbors and other people, and that's how you're making interest. And so you can't get all of your money instantaneously, everyone at the same time. It just doesn't work. Okay, so what the second table has is a different interest rate. So I think what we're doing now is we're going to use 5 years for the whole thing, but now we're changing interest rates. So we can still kind of go back in and use what we had before, but I'm going to go in and delete a couple of things, delete, and make this 0.05 times 1. Or maybe you just want to type the whole thing in again. So it's 4,500, and just for this first one, I'll write out that works. So it's 4,500 times e to the 0.05 times 5, because it's, or I'm sorry, times, okay, this is 1%, so I need to make it 0.01 times 5. Eventually, it'll come out of my mouth, and I will write it and type it correctly, because we're changing the interest rate to 1%, so that'll be 0.01, but the years are staying 5. Okay, I think I finally got it. So now it's going to be 4730.72. Okay, so for interest rate of 1%, that's what we would make. And so instead of changing the time, this time we can go ahead and copy and paste and change 1% to 2%, which is 0.02. We get 49.73, and this will round up to 27 cents. And go in. Well, you know, there's only so many things that are probably legal. But, okay, so 52.28, 25 cents. And theoretically, we're just changing the numbers and kind of seeing how this goes. And I'm just writing them out. So I'm going in, changing from 4% now to 5%. I know this is thrilling. We get 57.78 and 11 cents. And then the last one is 6%. So I'm making sure I'm changing the interest rate and not the time.
I don't have to write the 45 times e to the 0.01 times 5 every time.
Because we're just copying and pasting on the calculator.
I mean, like on the paper.
So if you're using your calculator and copying and pasting, show me how you set it up the first time. And then yes, we're going to use the calculator to do the rest. Okay, so yeah, I'm going to keep this here for a second. Shh. So keep this here for just a second and you can kind of compare things that are happening. So which made a bigger difference, changing the time or changing the interest rate?
Changing the interest rate.
Changing the interest rate definitely made a bigger change, which I think is what they're trying to get us to see there. So I know some people are still writing it down. Yes. Yes. And then when we get down to number 2, we're going to just set up the equation and type it in, and that'll be more like what you'll see on assignments. Okay, so I'm going to scoot this up. I think there's still, has everybody pretty much got it?
I'm so close.
Okay.
I didn't know that we could just.
I did say it out loud.
I was too busy.
I know.
The equation down.
I know. So this is everybody all the time when I teach. Our listening skills as a society are like going. So I always like to point out, I did say it.
I heard everything else you said.
Good. Well, that's good because that means you didn't miss much. And if you had written it out on every single one, it would have just taken you longer.
That's the thing. I understood it.
But I was like, okay, we're only going to write this once, but that's okay. Okay, so we're going to come down here. If $1,673 is invested at an interest rate of 2.7% per year. So per year, this just means sometimes they will say annually. That is not how it's compounded because they're saying, okay, this is compounded continuously. What is the value? So as soon as I see continuously, I know that I'm going to use this formula instead of the other one. If it then, because you're going to have an annual interest rate, but then it could be compounded quarterly or compounded semi-annually or whatever. So we're going to put it all in. So the principal is the 1,673. And then times E, my interest rate's 2.7%. So somebody change that to a decimal.
0.27.
So 0.027. Okay, I was understanding it, but making sure. And then that'll be times the time. So sometimes they put these in parentheses just to, which is 25 years. So that would be a very long time to leave that in. Let's see what happens. So 1673 times E to the 0.027 times 25. And it comes out $3,285, and it'll round up to 83 cents. So you basically doubled your money.
But it took 25 years.
It did take 25 years, but they didn't have to do anything. It just sat there. So
You'd be adding money with your paychecks and stuff, so it'd probably increase more than that actually.
it depends. If it's something that you are adding to more, then it would add more. This is just putting in one amount one time and letting it sit. But for not doing anything and it doubling, that's something. Okay, so let's go on to the next thing. Now, we're mostly going to be using that PERT formula, but I wanted you guys to see some other real-world applications. The more real-world you get, the more interesting the math gets. And so when people are like, when is this used in the real world? Sometimes it's hard to explain because what I'm teaching you are the building blocks to something a lot bigger. We're giving you like a basis so that if you want to go into a math or science field, you'll be able to jump into those college classes. So on number 3, it says when a specific medical drug is given to a patient, the number of milligrams remaining in the patient's bloodstream after T hours is modeled by this function. So basically, there's some information here. This is negative. That means that it's going to be going down instead of up. And this is actually the original amount of milligrams they put in the system. So instead of principal, this is your original amount of milligrams of whatever that drug is. So it says how many milligrams of the drug remains in the patient's bloodstream after 6 hours if that's what is initially given. So I just have to put 6 in where the T is. And if I write that right there, I don't even have to write it out because I got it right there. So 37.6 times e to the negative 0.24 times 6. We will in a second. It's actually really fascinating when you start talking about drugs being eliminated from systems or radioactive. Okay, so after 6 hours, there's 8.9 grams left in the system, or milligrams. I guess it's in milligrams left. So this is why with a lot of medicines, you have to take it every 4 hours, every 6 hours, every 12 hours, depending on how it's been formulated to work through your system. And that's how you kind of keep it above a certain level. When you're taking antibiotics, I had to find this. I've got a really interesting lab somewhere where somebody forgets to take one antibiotic pill, and then you see they take it later, and that one drop, it takes forever to get back up to the level it's actually going to kill the bacteria. It's interesting. There's a reason they give it to you to take so often for so long, is they want to make sure if something gets flubbed in the middle, that it's still going to die. Shh, we are recording. Okay, let's look at the next one. The growth, or actually you guys wanted to graph this. Let's graph this. So let's go into our y equals, and I'm going to go down and use my number 2 because it's already, so 37.6, and then e to the negative 0.24, and then instead of t, we'll put in x. So if you want to graph it, you got to have a variable there, not a number. So we'll put x there where that t was. And then I have no idea how this is going to graph. I'm probably going to have to change my window for sure. So I'm going to go into, oh, there it is. You can kind of see it over there. So I know that it's starting with an initial amount of almost 38 milligrams. So my window, my y value needs to go up to probably 40, or that's, I just did that in the wrong one. Y max probably needs to be like 40. And then you'll get to see kind of where it starts up here at 37.6, and then eventually it will kind of taper down to 0.
Do the trace to see.
So if you do trace, you can kind of see roughly, so there's about, after 1 hour, you have 29 left. After 2 hours, you have about 22.5. 3 hours is 18. So how it traces might be different on yours than it is on mine. It depends on if you changed your window. They're slightly different calculators, but you can get in general. If you want exact amounts, go over to the table. So hit second and table, and hang on, I got to go back to 0. Okay, here we go. So if I go back to my table, at 0, I had 37.6, because that's what was in there. And you can see it goes 29.5, 23.2, 18.3, 14.3, 11.3, 8.9 is where we just were, 7.005. So do you guys see where the calculator might be useful? If they ask you the same problem and they wanted to know 6 hours, 12 hours, 24 hours, I could put this in once and get all of those. So that's where this is nice. And actually, let's see where it's at after 12 hours. So after 12 hours, they only have 2 milligrams left. And if you go to 24 hours, they took that one pill. 24 hours later, they have like 1/10 of a milligram left.
I wonder how
So,
long
so when they do certain scans, sometimes they'll do, I had to have an MRI done with contrast, and so they'll hook you up to an IV, and they like do the MRI, and then they shoot the stuff into you, and they do it again. And so it's radioactive stuff, but it gets out of your system like really, really fast. So they do it like while you're in the MRI machine and take that, and within 24 hours, it's pretty much out of your system. It's not something that's going to be there and hurt you long term. But that way they'll have the contrast of that radioactive substance when they look at the scans. It's really weird and super cold when they shoot that up your arm. But this just kind of shows you with certain medicines, like I have certain medicines I have to take every single day. If I miss it, I don't immediately notice, but that amount, or let me go back to the graph, that amount does drop off, and after a certain number of hours, I'm like, oh no, I didn't take it. And then when you take it again, it comes back up, but it does take a little bit to get back to that desired amount.
If you have like a screw or anything in your body, you can't have an MRI, right?
Not for that part of your body. So you can have a screw if it's like in your foot, but they're doing an MRI of your arm, you can do that. They just don't want to put it inside the machine because the magnet will rip the screw out through your skin, which I'm assuming is unpleasant. Okay. This is going to be the best video ever. Okay, let's go down to number 4, look at a different application. So the growth of an initial 100 million bacteria is modeled by this equation, where T is modeled in hours, and G of T, or just G, if you want to call it, is measured in millions. After 3.5 days, how many bacteria will there be? So this one has a positive power. It's going to be going up. So let's go in and we'll just go back to our original screen. So we'll do 100 and then e to the 8 times 3.5 days. So I would be putting 3.5 in where that t is. So since it's a worksheet, I can kind of write it there. If it were on paper, I'd want to write out at least once how I was setting that up. And so, hang on, did I do that right? Modeled 100 million. You're right. You are absolutely right. So how would I do? So 3.5 days times 24 hours means it's actually 84 that's going to go in. Good catch. And that's a mistake that obviously it's easy to make. So let me go back in and capture this. Instead of 3.5, I'm going to put in 24 hours. And then it'll look right, maybe. So the initial million is, okay, so this is measured in millions. I still feel like that should be going up.
It should, because it should be 3.5.
Oh, wait, look, there's a little e over here. That means that this decimal point moves over 85 places. So it's 2.4 times 10 to the 85th power, and this is measured in million bacteria. It's a lot. So sometimes we gotta pay attention to the little e. So it just kind of is like, wait, why is that not there? And this actually, huh?
If you have $1 compounded at a 100% interest rate for 100 years, you will have 2.6 times 10 to the 4th power dollars.
Okay, I think I'm gonna stop here for right now.